the first attempt and the beginning of AI all starts with psychologist Frank Rosenblatt in 1957. In that time, he developed what was called perceptron. A perceptron was a digital neural network that was designed to mimic a few brain neurons. Frank's first task for the network was to classify images into two categories. He scanned in images of men and women, and he hypothesized that over time, the network would learn the differences between men and women, or at least see the patterns that made men look like men and women like women. Just a year later, the media caught onto the idea and the hype was strong. In 1958, the New York Times reported that the perceptron was to be, quote, the embryo of an electronic computer that will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence, end quote. Unfortunately for Frank, despite the hype, his neural network system didn't work very well at all. This was because he only used a single layer of artificial neurons, making it extremely limited in what it could do. And even worse, there wasn't much that could be done about it at the time. Computers of that day could only handle this simple setup. These problems were never solved, and by 1969, the computer science community had abandoned the idea, and with that, AI was dead. Everyone may have given up on the idea, but decades later, a keen computer scientist by the name of Geoffrey Hinton thought that everyone else was just plain wrong. He theorized that the human brain was indeed a neural network, and the human brain evidently made for an incredibly powerful system. To him, this was as much proof as he needed. Artificial neural networks had to work somehow. Maybe they just needed some tweaking. Hinton saw the genius in the idea that everyone else missed.
It seemed to me there's no other way the brain could work. It has to work by learning the strengths of connections. And if you want to make a device do something intelligent, you've got two options. You can program it or it can learn.
Right.
And we certainly weren't programmed, so we had to learn. So this had to be the right way to go. So you have relatively simple processing elements that are very loosely models of neurons. They have connections coming in. Each connection has a weight on it.
Just for clarification, a node is an artificial neuron, and a weight represents the strength of connections between neurons.
That weight can be changed to do learning, and what a neuron does is take the activities on the connections times the weights, adds them all up, and then decides whether to send an output, and if it gets a big enough sum, it sends an output. If the sum is negative, it doesn't send anything. And all you have to do is just wire up a gazillion of those, just figure out how to change the weights, and it'll do anything. It's just a question of how you change the weights.
Geoffrey Hinton is a superstar in the AI world. Having authored 200 peer-reviewed publications, Hinton was instrumental in the fundamental research that brought about the AI revolution. After studying psychology, Hinton moved into computer science and pursued his lifelong quest of modelling the brain. Originally from Britain in the UK, he moved to the University of Toronto. In Toronto, he would go on to develop multi-layered neural networks. He and his team quickly realized that the problem with Frank Rosenblatt's single-layer approach was that more layers were needed in the network to allow for much greater capabilities, and the computers of the day were now powerful enough to handle it. This multi-layer approach solved the problem that Frank Rosenblatt had. The neural networks were much more capable. Today, we call this multi-layered approach a deep neural network. In 1985, Hinton co-authored a paper which introduced the Boltzmann machine. Boltzmann machines are the fundamental building blocks of early deep neural networks. You can think of them like the Ford Model T of neural networks. Without getting into the details, the concept is to have groups or layers of neurons communicate in such a way where each artificial neuron learns a very basic feature from any data. For example, each neuron could represent a pixel in an image that the network is trying to learn. Long story short, the result is a program that can make accurate guesses and predictions about data it's never seen before. Soon, others began innovations based off deep neural networks. A self-driving car was built in the late 80s on neural networks, and later in the 90s, a man by the name of Yan LeCun would build a program which recognized handwritten digits. This program would go on to be used widely, but Yan LeCun would also go on to be an AI pioneer in his own right. Lee Kuhn would study under Geoffrey Hinton and would lead the research that made Hinton's theory of backpropagation a reality. Backpropagation, in simple terms, is the process of computers learning from their mistakes and hence becoming better at a given task, much the same way humans learn from trial and error. However, the idea of AI being used for much more was short-lived. The field was stifled by two problems. One, slow and inadequate computing power, and two, a lack of data. A burst of investor confidence was eventually met with disappointment, and the research money began drying up. Geoffrey would become ridiculed and forced to the sidelines of the computer science community. He was seen as a fool for his long-standing faith in a failed idea. Undeterred by the opinion of his colleagues, Hinton pursued his dream with an unfazed obsession. In 2006, the world had finally caught up to him. Computer processing speed had grown significantly since the 90s. Moore's law, observed by Intel's co-founder Gordon Moore, stated that the number of transistors per square inch doubles about every 2 years. This meant that computers were growing in processing power exponentially. That's the first problem solved. Meanwhile, thanks to the advent of the internet some 15 years earlier, a wealth of data had been acquired, and this solved the second problem.
But you know, I think about this, and what about this internet thing? Do you know anything about that?
Sure.
What the hell is that exactly?
Well, it's become a place where people are publishing information.
Right.
So everybody can have their own homepage, companies are there, the latest information. It's wild what's going on. You can send electronic mail to people. It is the big new thing.
The ingredients of AI were now there. The computers were powerful enough, and there was enough data to play with. By 2012, the ridiculed Geoffrey Hinton was now 64 years of age. Continuing the work wasn't an easy task. Hinton was forced to permanently stand due to a back injury that would cause a disc to slip out whenever he sat down. The birth of the modern AI movement can be traced back to a single date, September 30th, 2012. On this day, Geoffrey and his team created the first artificial deep neural network to be used on a widely known benchmark image recognition test called ImageNet. Hinton's program was called AlexNet, and when it was unleashed on this date, it had performance like no one had ever seen. AlexNet destroyed the competition, scoring an over 75% success rate, 41% better than the best previous attempt. This one event showed the world that artificial neural networks were indeed something special. This sent an earthquake through the science community. A wave of neural net innovations began, and soon the world took notice. After this point, everyone began using neural networks in the Image Benchmark Challenge, and the accuracy of identifying objects rose from Hinton's 75% to 97% in just 7 years. For context, 97% accuracy is surpassing the human ability to recognize objects. Computers recognizing objects better than humans has never happened in history. Soon, the floodgates of research and the general interest in neural nets would change the world. By the late 2010s, image recognition was commonplace, even recognizing disease and medical imaging. Images were just the beginning. Soon neural net AI was tackling video, speech, science, and even games. Today, we see AI everywhere. Tesla, among many companies, has created a sophisticated self-driving AI, which is already sharing the road with humans. It is predicted that self-driving cars will reduce accidents by up to 90%, while smart traffic lights would reduce travel time by 26%. Netflix and YouTube even uses AI to learn what shows you watch and recommend new ones. Uber uses machine learning AI to determine surge pricing, your ride's estimated time of arrival, and how to optimize the services to avoid detours. There's also a new interesting hide-and-seek AI as shown here by the YouTube channel 2 Minute Papers. In this scenario, two AI teams battle against each other, one outsmarting the other as each round of the game persisted. After a given time, one of the teams figured out how to break the game's physics engine in order to win. This was something that the researchers never anticipated. It's a potent demonstration of AI's problem-solving abilities. The popular app, TikTok, is completely AI-driven, leading to its popularity, as we've covered in a previous video. So now AI is everywhere. It's in our daily lives, even if we're not aware of it. Of course, there's many examples of AI being used, but perhaps the most interesting uses will come after we reach singularity. Singularity is the concept of AI surpassing human intelligence. After this point, what happens is a bit of an open-ended question. By default, computers would be able to reinvent better versions of themselves. They could progress fields such as medicine and science without human direction. AlphaGo Zero is a graphic illustration of the possible rate of this progress. In 2016, experts thought that it would take an AI around 12 years to beat a human at the ancient game of Go, a game with virtually infinite possibilities, and a game that relies on human intuition to master. But the experts were very wrong. Their 12-year prediction in reality was actually 0. An AI did in fact beat the Grandmaster of Go in that very same 2016 year. The next version of the AI, AlphaGo Zero, learned to play the game from scratch and beat the previous version 100 games to 0 in just 3 days. AlphaGo Zero was so good that it was able to be applied to other things that it wasn't trained for, like lowering the power usage on Google's data centers. The new breeds of AI could even begin to invent new tools that humans would never be able to fathom. Dr. Richard Sutton of the University of Alberta says that singularity is widely estimated to happen around 2040. By 2030, we should have the hardware capability to achieve this, allowing for another decade for people like Sutton to make the code that achieves singularity. It's a rather unnerving thought that in about a decade, we may have computers that are smarter than us.
How many years away do you think we are from a neural network being able to do anything that a brain can do?
I don't think it'll happen in the next 5 years. Beyond that, it's all a kind of fog, so I'd be very cautious about making a prediction.
Is there anything about this that makes you nervous?
In the very long run, yes. I mean, obviously, having other super intelligent beings who are more intelligent than us is something to be nervous about. It's not going to happen for a long time, but it is something to be nervous about in the long run.
What aspect of it makes you nervous?
Well, will they be nice to us? Also, the movies always portray it as an individual intelligence. I think it may be that it goes in a different direction, where we sort of develop jointly with these things. So the things aren't fully autonomous, they're developed to help us. They're like personal assistants. And we'll develop with them. And it'll be more of a symbiosis than a rivalry.
So we've seen the future. So where are the pioneers now? Currently, Geoffrey Hinton divides his time between his roles as a professor at the University of Toronto and vice president at Google. Lee Kun is vice president at Facebook. Both of these pioneers had won the 2018 Turing Award for their contribution to AI. Named after the father of computer science, Alan Turing, who created a machine to decipher German codes, virtually ending World War II, the Alan Turing Prize is considered the Nobel Prize of computing. Artificial intelligence has rapidly grown in the span of less than 2 decades, from the fringes of science to the centerpiece of the world. Without the work of these pioneers who refuse to give up, our future may be very different. Perhaps we don't fully understand the potential of AI, but nonetheless, it should be obvious that their work has created a significant point in human history. Much like the invention of fire, the wheel, electricity, computers, and the internet, artificial intelligence will be one of humanity's greatest tools. Due to his back condition, Geoffrey Hinton hasn't sat down for the last 12 years. At 71, we hope Hinton will keep standing for many more years to come. While AI is helping many people today, we can only hope that it will continually be used for good in the future. So thanks for watching. That's our look at the people who created AI and the history of artificial intelligence itself.